Hello everyone, welcome back to our session on transportation model. So in the previous lecture, we have studied with what exactly is transportation model, and we have seen four important methods of solving the transportation model, which were number 1, northwest corner method, number 2, row minima method, number 3, column minima method, and number 4, least cost method. So we are yet to complete the fifth and the most important method, that is Vogel approximation method. Before that, let us focus on unbalanced transportation problem. Now we know that the transportation model will be called as a balanced transportation model if the total demand is equal to total supply. Now in this problem, if we add the total demand, so our total demand is equal to 90 and our total supply is equal to 150. So we can conclude that as the total demand is not equal to total supply, thus this is not a balanced transportation problem. So for solving the unbalanced transportation problem, it gets important for us to convert it into balanced first, and then we can solve it by any of the method. Okay. So here we can say that supply minus demand is equal to 150 minus 90, that is 60. As far as this matrix is concerned, 60 demand is in short of the supply, and we can see from the matrix that here each and every column represents the demand. So to make demand equals to supply, we need to add one column. So that's why this 3 by 4 matrix will be getting converted into 3 by 5 matrix, where we will be adding one column whose demand will be obviously equal to 60. So let us convert this unbalanced transportation problem into balanced transportation problem. We will be drawing the matrix as it is. So 12, 18, 13, 20, 17, 11, 16, 15, 11, 10, 14, 13. Okay, the demand is 20, 25, 10, 35, and the supply is 50, 60 and 40. So to convert this problem into a balanced numerical, we have added one column where the cell value will be 0. So this will be the cell value and the demand will be 60. Now if we add the total demand and if we add the total supply, we get the value equals to 150. So it means that we have converted the unbalanced transportation model into a balanced transportation model. Now let us solve this numerical by northwest corner method. Okay, we have already seen the northwest corner method in the previous session, so now let us solve it a little bit faster. So 12 is the northwest corner, so we can allot 20 or 50. So we will allot 20. So this 20 becomes 0 and this 50 becomes 30. So this column has been cancelled. Now 18 is the northwest corner, so we can allocate 25 or 30. We will allocate 25. So this 25 becomes 0 and this 30 becomes 5. Again we can scratch the column. Next 13 is the northwest corner. We can allocate 5 or 10, so we will allocate 5. So this 5 becomes 0 and this 10 becomes 5. Now we will be scratching the row. Again 16 is the northwest corner, so now we can allocate here 5. So this 5 becomes 0 and this 60 becomes 55. So we will be scratching the column. Next, this 15 is the northwest corner, so we can allocate 35 only. So this 35 becomes 0 and this 55 becomes 20. And we will scratch the column. Here 0 is the northwest corner, so we can allocate 20 here. So this 20 becomes 0 and this 60 becomes 40. And finally we are left with only one cell value, that is 0. So we will be allocating all the 40 which is left to that particular cell value. So we have solved this particular method by northwest corner method. Let us just identify the allocated values. So we have total 7 allocated values. Okay, we can write down the total transportation cost is 12 into 20 plus 18 into 25 plus 13 into 5 plus 16 into 5 plus 15 into 35 plus 0 into 20 plus 0 into 40. So the total transportation cost will be rupees 1360 rupees. So this is the process in which we convert the unbalanced transportation problem to balanced one, and then we solve it by any of our conventional method. Okay, so now let us understand the fifth and the most important method for solving the transportation model, which is called as Vogel's approximation method, or it is also referred as the method of penalties or regret method. So here on your screen you can see a numerical in which we have 3 factories and 4 warehouses. The goods from all these 3 factories are to be transported to these warehouses, and the unit cost for the transportation is given in the matrix. Here we have the total demand for each warehouse, or the requirement is mentioned, and the capacity of each factory to supply is also given. So let us add all the requirement or demand. So if we add all the requirement or demand, we get the value equals to 34, and similarly the total supply or capacity is also 34. So this is a balanced transportation problem. Okay, now this balanced transportation problem we are supposed to solve it by Vogel's approximation method. So in Vogel's approximation method, what we do is we draw a horizontal line and then a vertical line, and beyond these lines we will be giving the penalties. Okay, so now this method is called as the penalty method. Okay, now what exactly penalty is? The important point is each row and each column will have a penalty. So here we have 4 columns and 3 rows, so total we have 7 rows plus columns. So in the first step we will have 7 penalties. Now what exactly penalty is? So to find the penalty of a particular row or a column, identify the least element or the least cell value in that row or column, then identify the next bigger value and find the difference between them. That will be the penalty. So for example, in the first column the least cell value is 19 and the next bigger value is 40. So 40 minus 19, the penalty will be 21. Similarly, for the next column, the smallest value is 8 and the next biggest value is 30. So the penalty will be equal to 22. Likewise, calculate the penalty of all the columns and all the rows. So the penalty of the third column is 10, of the fourth column is also 10. The penalty of the first row is 19 minus 10, that is 9. The second row is 40 minus 30, that is 10. And the third row is 20 minus 8, that will be 12. So we have already calculated all the 7 penalties. Now we will allocate in that row or column whose penalty is highest. So if we compare all the 7 penalties, the penalty of second column, that is 22, is highest. So now we will enter in this particular column. Now as far as this column is concerned, this column consists of 3 cell elements, that is 30, 30 and 8. We will be allocating to the minimum cell value. Minimum cell value is 8, so we will be allocating there. So to allocate at this particular cell value, we have 8 demand and 18 supply, so we can allocate here 8. So this 8 gets cancelled and this 18 gets reduced to 10. So now we can scratch the column. Again carry out same procedure, find the penalty. So the penalty of the first column is 21, the second column is already eliminated. The penalty of the next column is 10 and 10. The penalty of the first row is 9. The penalty of second row is again 20 now, because the smallest element is 40 and next biggest is 60. And here also we have penalty as 20. Now out of these 6 penalties, the penalty first column is highest. So we will enter through this column and the allocation will be at the lowest cell value, that is 19. So at 19 we can allocate 5. So this 5 will become 0 and this 7 will become 2. We will again scratch the next column. Again carry out the same procedure, write down the penalties. So the penalties for first 2 column will be dash because those are already eliminated. The penalty for third and column fourth will be 10. The penalty for first row will be now 50 and the difference between 50 and 10, that is 40. For the second row it will be 20 and for the third row it will be 50. Now out of these 5 penalties, the highest penalty is to row number 3. So here we will make the entry and we will enter at the least cell value, that is 20. So we will allocate 10 here, so it will be 0 and 4. We can scratch the row. Again carrying out same procedure. Here now the penalty will be 10 and 50. Here the penalty will be 40 and 20. So out of these 4 penalties, the highest penalty is in the column number 4. So here we will allocate at the least cell value, that is 10. So allocation will be 2. So this becomes 0 and this becomes 2. So now we can scratch the row. Next, now in the third column we have only one cell value, so the penalty will be directly equal to 40. In the fourth column it will be 60, and in the second row it will be 60 minus 40, that is 20. So the highest penalty again it is in the column number 4. So here we will do the allocations. So this 2 will become 0 and this will become 7. And now finally we have only one cell value. So the penalties will be dash, dash, 40, dash, dash, 40 and dash. Okay, and now we will enter at this 40. So the allocation will be 7, so it will be 0 and 0. So with this we have completed the numerical by Vogel's approximation method. Let us mark down the allocated cell value. So this is the first cell value, second, third, fourth, fifth and sixth. Okay, so we can write down number of non-negative allocations, which is 6, and m plus n minus 1, which is number of rows 3 plus number of columns 4 minus 1, that is 6. Both the values are same, therefore the solution is non-degenerative basic feasible solution. Okay, And if we find the transportation cost, transportation cost will be 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. If we do the calculations, then the total transportation cost will be rupees 779. So this is all about Vogel's approximation method. So we have already discussed all the 5 methods in the transportation model, and all the 5 methods were used for calculation of basic feasible solution. But none of the method is giving us the optimal solution. So in the upcoming session, we will study about the method, that is modified distribution method, which will give us the optimal solution. Thank you very much.